So we've had a lot of questions over the last few weeks about the programming language that Steven's using to build the authoring tools, Racket. We've gotten a lot of questions like,
What is Racket? Why Racket? What makes Racket special?
we've heard a little bit already from Steven about why he chose Racket in Patreon update number 8, but I wanted to sit down with some members of the Racket community to get their take on Racket and why it's such a cool language. The first Racketeer that I interviewed is Jay McCarthy. He is a professor at Mass Lowell, and he's highly involved in the Racket ecosystem. He'll tell us a little bit about his relationship with the Racket community and why he thinks it's such a useful language. We're going to start right in the middle of his story, which begins with a course that he took in undergrad with Matthias Felisen, who really is the founder of the Racket programming language.
And he spoke, and he talked about this thing called the Racket web server. And it was really interesting because he talked about something that I had actually tried to implement a very similar technique in this massive Perl program that I was responsible for.
Perl, yes.
Yeah. And I was just like, wow, that's just such a better way to do it. And I got really into it. And basically I sort of, at that time, sort of converted all of my home programming to using Racket.
Cool.
And then when it was time to go to grad school, I knew what I wanted to do, and I knew that Racket would be a good place to work on that. So basically what I did is I just emailed all of the people who were behind Racket, and I said, could I be your PhD student?
Oh,
and
cool.
So I went to go work with Shreya and Krishnamurthy at Brown. And then I actually, became responsible for the Racket web server. And now I'm the maintainer of that. And since then I've been involved in lots of other projects related to it. So, I made the package system. I have so Matthew Flatt, he made our Scribble system for writing documentation. And I remember when I was getting ready for my wedding, I was the first person other than him writing documentation in Scribble. And among all the documentation, the oldest documentation that's written in Scribble is the web server documentation, because I was learning how to do it.
That's awesome.
Test out the stuff. So anyway, so I've been involved in Racket for a really long time. The last few years I've run the RacketCon conference.
Which is going to be online this year, right?
Yeah, this year it's going to be online on October 16th, 17th, and 18th.
Awesome. I just looked that up. I'm excited.
Now, there's not really one thing that I've worked on in Racket. There's kind of a bunch of different things I've worked on. So I manage the continuous integration system that's called Doctor. I do the package server. I do the web server. Racket is just kind of like a central thing about everything that I do. So basically, when I am at my computer, I have a web browser open and a terminal running Racket programs, so
yeah.
Whole personal life, all my internal processes are all, all based on Racket stuff.
That's awesome. What kind of value or pros do you think Racket has over other programming languages?
Yeah, so there are some people that are Racket maximalists that think that the only program that you'll ever need is Racket. And I try to be a little bit more, for me, I basically use Racket almost exclusively, but I have a good appreciation for other things. A big part of my, research has been in Coq and Haskell. So other languages, they're fine. But I think the thing that makes Racket special is that Racket is really designed to be extensible in a way that other languages just really can't fathom. So one way to think about that is that you can kind of think of all languages as being ways to make it so that you will limit the amount of repetition that you do when you're doing a project. So imagine that the only thing you had was a calculator. And the calculator, and not even a fancy calculator that can remember stuff, but just a normal pocket calculator. If you ever needed to have one computation and then save it for later, you would have to write it down on a piece of paper. So even a language that just introduced basically just the very idea of naming a value and being able to use it later, what that kind of does is it makes it so you can eliminate repetitions. And so most languages, obviously they have this feature, and they also have features functions, right? Where what functions do is they basically allow you to take a block of code and they allow you to make it so you don't have to copy it a second time, but you can have one copy of it and then basically put a little hole in it. And that hole is where a variable goes. and then you can then apply that function later on.
Mhm.
So pretty much all abstraction features in languages come from this idea of eliminating repetition. So another thing would be like, if you think about objects and classes, like the main thing that they are doing is they're making it so that your code doesn't have to have a whole bunch of if statements. Like imagine that you didn't have classes and you would have code over here that said, did I get a cat or did I get a dog? And over here you would say, did I get a cat or did I get a dog?
Yeah.
Instead, what you do is you just call a method in this spot and a method in that spot. And then dog and cat internally decide what function will be done. And because they have the same common interface, that means that you don't have to write code specifically for cats and specifically for dogs. Yeah, so for most programming languages, this is really the end of where they start, where their abstractions stop. So they have values, they have functions, they have classes, but they don't have anything more than that. And one of the kind of the fundamental ideas of Racket is how can we make a language that there is no end to the abstractions that are possible? And one of the fundamental things that you do with that is that you want something that's like a function, but it doesn't operate on values. Instead, it operates on entire programs themselves. And so most people who have heard of Racket or languages in the sort of the Lisp scheme family have heard of macros. And basically, this is what macros are. They're a way of making a little piece of functionality that is parameterized not over a value, like a function is, but over an arbitrary computation. And not like a computation that's hidden away behind a function, but instead, like you can think of it as the text of the computation. Although that is kind of like the fundamental idea, we don't want to just stop there and say, well, we can now like copy code from arbitrary places and inject it in. We want to do that in a way that actually allows you to make abstractions. And so what do I mean by an abstraction? So like, consider the example of a function again. If I told you that there's this function f, and it takes a number and it returns another number, you can use that function, but you don't have to know the details about how f does it. Now, obviously to use f well, you might want to know like, well, what does it do with the number? So you might say like, well, this is a function that like doubles. And so one way to double is I could do x plus x. Another way I could double is I could do x times 2. And so there are different ways of implementing the same idea when it comes to functions. And you as a consumer of a function can't tell the difference between the ways it's been implemented. And this is actually a feature because it means that you can't accidentally tailor your program to one version or the other. So that means that your program is now less prone to this copy problem, because I might have to make one version of my program for the x plus x version and another one for the 2 times x. But because the function itself is an abstraction, the outside world can't tell the difference between these, and therefore I only need to write one version of it. So it turns out when it comes to things like macros, this idea of having an abstraction that's parameterized not over a value, but over code, it's very hard to make abstractions like that. Because basically the details of what the macro does become really important. So for instance, does it introduce a name? Like imagine that it introduced a name, and then when you called it, like, could you see the name that it introduced? Because if it did, then that means that it wouldn't be an abstraction because you'd be able to tell the difference between one that used the name X versus one that used the name Y.
Yeah.
So basically what the research program of Racket has been is how can we take this idea of there's no limit to the abstractions and make it so that they are truly abstractions where they abstract over the details of how they're implemented. So that is like, that's like the theory egghead explanation for what makes Racket special, okay?
Yeah.
So, but that's like that, if you are an expert, that's the how of why it's special. But for a user, like, what is it, what does it feel like? What's the thing that's special about it? I think the thing that's special is that we never want a Racket programmer to be in a position where they say, I can't do this because the stupid language does blah. And in my experience, I like many programming languages. You know what I mean? I write lots of C programs. I write lots of Haskell programs. I like Coq. I like lots of different languages. I always have that experience. And when I talk to students, when I talk to people who are, new programmers, they always have these moments where the language gets in their way. And there's
Yeah.
nothing they can do about it. You might say like, oh, well, it's open source software, so go make a patch to Python and improve it. But that's not realistic, right? Because Python is not actually designed to be extensible in this way. In contrast, Racket is designed to be extensible in this way. There's a high performance virtual machining compiler, just like other languages. But on top of that sits your program. In your program, from within it, you can add stuff to the compiler. And when you add stuff to the compiler, you can use that to solve your problems. Now, in my experience, most programmers who work on Racket don't actually do that very often. In the same way that I could maintain my own car and install aftermarket mufflers and things like that and make it go a little bit faster. You know what I mean? I could do that, but I personally don't.
Yeah.
But what happens is that since this is possible for Racket, there's a vibrant community of new ideas and new kinds of abstractions that are available for Racket programmers that in other communities, you typically have to totally switch languages to use. Whereas sometimes what will happen, and I always enjoy this, someone out in the world will come up with a new way of making a programming language. They'll have this new idea, and that new idea will there's a whole new language for that. And someone will take a summer and they'll say, how can I add that to Racket? And they can just implement a library that doesn't change any of the virtual machine, doesn't have to interact with the compiler. And now this new feature is now part of Racket. And so in that sense, it's kind of like future-proof to new ideas that people might have about new kinds of abstractions that you might want to have in the future. And so I find that really, really interesting. And I think that that's a big part of what's happening with CodeSpells, where what's going on with CodeSpells is that Stephen is basically saying, I'm making a new kind of language. I mean, he kind of knows what he wants to do. He kind of doesn't know what he wants to do. But what he does know is that it's an experiment. Now, imagine if the only way that he could do that is to start writing a compiler that turns his new language into x86 assembly and has to deal with all the issues about how do I define a function and how do I manipulate these kinds of things. I mean, it could be done, but we'll have to go check on him in 15 years.
Yes.
And then maybe it would be ready, okay? But in contrast, what Racket does is it provides this really powerful platform for doing those kinds of experiments and then sharing those things with other people.
Do you have any favorite projects?
Well, okay, so I mean, I mentioned it before, and maybe this shows the kind of person that I am for thinking it's important, but the Scribble documentation in Racket is really amazing. So when you look at Racket documentation, whenever there's a code sample, every word and every function in the code sample is a link to the definition of that function and how to use it. Now, obviously, any language could make documentation like that. And what they would do is they would have to go and manually annotate every single function and say, this is a link to here and this is a link to there. And that would be taking an extremely long amount of time. And so they don't do that. So I'm not aware of any language that actually works this way, where the documentation, you have these links. And the thing is that those links basically come for free because of the way that Scribble works. And Scribble gets this feature because of the way that Racket works. Because basically how Scribble works is it's a programming language where when you run the program, it doesn't produce a number like 5 or an image or a GUI. Instead, what happens when you run it is it produces a text, like a documentation page. And the thing is that when you look at a code sample in Scribble, those functions, if we were to go look at the source code, those functions are really there. They're not text. It's actually that function. And since it's actually that function, that means that the language has to know, well, which function are you calling? And since it knows what function you're calling, it can then say, well, where's the documentation for that? Because it has a database of where the documentation is for every single function. And that is a really novel use of how Racket works. So I find that really impressive. Another thing that I really like about Racket, so there's this idea in the world of gradual typing. So many people, when they first start programming, they use a language that has no limitations, Python or JavaScript. But then as a program gets bigger and more complicated, they're really nervous about there being a problem in their program. And so at some point, people might say, well, let's switch and use a new programming language for my big projects. And that happens in the life of individuals, and sometimes it happens in the life of programmers, of companies. But one of the problems is that by the time you know that something is big, you might already have written half of the thing and it's already 10,000 lines, and now you really wish you had, something to watch your back. And so basically what typed Racket does is it allows you to take your big program that's split up into a whole bunch of different modules and one by one turn them into ones that have a type system, and it makes sure that things are checked nicely. So those are both kind of like a programming language theorist features. You know what I mean? Like me as like a PL person, like those are really exciting features. But like I have this other side of my life where like downstairs, my son, so I've got 5 kids, and my son is working on his own little video games.
Nice.
And we really, really like Pico 8 and Tick 80. They're basically these like little like self-contained little game consoles where you can like write programs in Lua and stuff like that, and they have like integrated editing environments, which are pretty nice. But Lua is of course really painful to use, especially for me. But anyways, so I really like building like like interactive applications and games and things like that. So I have this library that's called Lux and this other library called Node Lambda. And basically what they do is they make it so you can write like functionally reactive programs where you basically define like a model view controller thing. So you define like your game model, you describe a view function that renders it, and you describe this controller that will take user input and then update the model and then drive the rendering of it with the view. And then, so that's like what Lux is. And then what Mode Lambda does is Mode Lambda is basically, I sort of imagine, the way that I kind of conceive of it is it is like, if we had like modern graphics cards and we wanted to make the Super Nintendo, what Super Nintendo would we make today? And so it has like, so it's basically like a high performance 2D OpenGL graphics engine for doing all the kinds of effects that the Super Nintendo had, like the Mode 7 thing where it could like rotate the screen and like scale and stuff like that. And it's very convenient to work with. And so I really like building things like that. And I have dreams of leaving this professor game behind and working on cool arcade games all of the time. But maybe when the kids are through college.
Yeah, that can be retirement later, right? Well, if somebody wanted to start diving into Racket and learning Racket, are there any like specific resources you would point them to?
So there's kind of 2 angles to talk about this. There's one is, imagine that I want to embark on the journey of becoming a programmer and all that it entails to become a programmer. Like in my experience, the way that most people become programmers is they kind of like teach themselves because there's no good textbook, there's no really good resources. I mean, there are lots of people like the stuff that you do that point people in the right direction, but like you're not going to go take after school activities for 5 years and then have a job as a professional software developer.
No way. Yeah.
You know what I mean?
Yeah.
Those are really just to help people understand that it's an available option and to get them interested and have experience with it. The same way that like, the whole rest of their education when they're in, K through 12, they're not like doing the work of a mathematician, but they're learning the basics of math so they can be ready to do it. So anyway, so Racket, the authors of Racket have this textbook called How to Design Programs, which is available for free online. So if you Google How to Design Programs, htdp.org. And it is an attempt to have a curriculum that teaches this is how to become a programmer. And it is very detailed in, like many exercises. This is what you should do. And you can find MOOCs that are based on this course, that are based on this textbook. So there's one out of Waterloo, I believe, if you want someone to help you walk through it. And that's kind of the side of like, I really want to be a programmer and I want to do it like the right way. And I want to do it the right way that these Racket guys say to do it. So that's kind of one way to learn it. And I think the other way to learn it is like, I'm already one of these, self-driven programmers who kind of has my own experience. And I just want to know like, how can I say for in this language? There's this idea that like, you already know how to program. You just want to like translate it into what you know. And I think that probably the best thing there is the Racket documentation. There's a section called the guide. And what the guide does is it walks through kind of like each area of Racket, like what the general features are, and gives you an introduction to like how those things work. I mean, of course there's like a tutorial, but the thing is that the tutorial is just like a taste. Like the tutorial basically tells you like, here's how to call a function and like, make sure that your braces are balanced. You know what I mean? Like really basic stuff. But at the end of it, you don't really feel like, well, what am I supposed to do now? You
Mm-hmm.
know? Whereas I think that if you're already a programmer, you have kind of like an idea of something that you want to do. I would say read the guide and then try to do it. You know, and I think in general, the best way to learn any language is not to read any book or take any class, is to pick a problem that you know that you could solve, but you don't know how to solve it in this language, and just commit yourself to solving it in this language. And from that experience, I mean, like, suppose that you're going to make your Pokemon game. You're probably not going to make the best Pokemon game because you're learning the language, but you're going to learn the language really well because you're working on a real problem that you actually care about. And I think that's probably the best way to do things. And kind of, you know, to comment a little bit more specifically about CodeSpells, you know, on Steven's blog, he wrote this thing where he said, I want to make it so it's fun to write documentation. And like, that's such an interesting idea. And I feel like part of that is like, how can you make it fun to like learn how to program? And I think that, you know, when you're like playing a good video game, like you're learning a skill. Like you're not learning a skill that you're going to go get a job out of. Of course, there are Fortnite, you know, professional Fortnite players.
Sure.
But what I mean, like, you know, when I'm playing Civilization 6, like I'm not going to be a city planner after that.
Probably not.
But like, yeah, hopefully not. But there are like concrete things that I'm learning. Like I'm learning how this system interacts, and I'm learning how this system interacts, and now I can combine this together and solve this bigger challenge. And I think that kind of like the dream that I have, in part for things like CodeSpells, is like, how can we make like a genuinely fun game that genuinely teaches the things that are interesting about programming? Because like when I learned how to program, I basically just wrote a whole big series of programs. Now, none of those programs caused tornadoes of turtles to attack my friends. You know what I mean? But if they had, that would have been great. Like I remember back when I was a little kid, like I had BASIC on my, you know, on my little DOS box, and I would make these programs that just had like a rectangle bouncing around the screen. I was like, it's just so pretty. You know what I mean? If that were like, you know, a torrent of toilets, you know, in the neighboring town, like that would be much more exciting.
No, definitely. Yeah. No, I totally agree. Yeah, and I think that really is the goal with CodeSpells, is like, if we can create an experience where it's just fun to explore and create these kinds of crazy toilet tornado spells or whatever, like people are going to get really interested in learning more.
And then also like kind of on the other side, like, you know, there's kind of like the introductory angle, which has a, you know, there's lots of room there for CodeSpells. But I think there's another kind of cool idea, which is like when I think about media out there that has magic in it, like I kind of don't like Harry Potter, that like, why should little kids be able to learn how to do any spells at all? Like, it could be like so incredibly challenging to do that you like train your whole life and like maybe you'll be able to do like 2 spells, you know? And so like, there's some media that are more like that. Like, you know, I mentioned to you in an email, there's this great book, The Magicians by Lev Grossman. And in it, the thing that's awesome about it is that basically like magicians learning magic is like going to grad school, and like, you know, people drop out because they can't handle it. And then when they finally do manage to cast a spell, like half of them kill themselves. So it's just like, you know, it's just really intense to do. And so anyway, so I would just love the idea of like, you know, imagine, you know, something like World of Warcraft, you know, like a game that's kind of fun on its own right, and you could play it as a norm. But you could also just dedicate yourself completely to the study of how this insane magic system works in it, and like figure out how to like really do something, and then just totally like, you know, wreak havoc and break the game, but, you know, in a way that was, you know, controlled in some sort of way that you couldn't just do it arbitrarily. I think that kind of thing is interesting. Like, you know, it's always kind of unsatisfying in like fantasy art when magic is commonplace. You know what I mean? It's like, why are there like hundreds of wizards walking around? I like the idea of so, you know, in terms of like role-playing games, you know, Dungeons and Dragons and things like that, there's this system called Dungeon World, and in Dungeon World you can play the wizard, and like when you play the wizard, you're one of 12 wizards in the entire universe.
Nice.
So it's, you know, it's a rare circumstance, kind of like in Lord of the Rings, right? In Lord of the Rings, there's basically, I think there are 5 wizards, and that's it. I really love those kinds of things, and I think that there's some space to experiment with like, what's a really Baroque way of programming that is weird, and like that would be kind of an interesting thing in CodeSpells. You know, there's a series of games, the Zachtronics games, where, they're ostensibly puzzle games, but really they're programming games where you're just programming this insane machine that like has just bizarre rules, and you just have to figure out how this thing works. And then once you learn how to do it, then you can do it. So I think the one that really hooked me the most is called Space Chem. And you're basically like designing these machines that like synthesize chemicals. And so you're like writing a program, and the program is like a 2-dimensional program that like sits on this grid, and the grid is like 8 by 10 or something like that. And every node in it is like a function that you can call. And like sometimes you'll have an idea for how to write something, but it's like literally too big, and so you can't write the program that way. You have to figure out some other way to write it.
Oh, cool.
And then programs have like weird interactions where like, you could put a function call here, but then it will like mess with the function calls around it. So you have to make sure that you have the other function call over here, but now you have to like, well, you have to like physically pass the arguments around and you have to figure out some way to get the arguments from one place to the other. So it basically like makes programming this like really bizarre puzzle. So anyway, so I love games like this. And I feel like something like that, people in the CodeSpells community could make a lot of cool things.
Yeah, no, I'm really excited that we're building it this time as a tool instead of just as a game, because I'm super curious to see like what all people come up with. Because like that Space Chem game sounds amazing. I'd never heard of it before. Is it on Steam or like?
Yeah, it's on Steam.
Yeah, okay, I'll check it out.
So yeah.
That's fascinating. Well, I don't want to use up too much of your time, and I really, really appreciate you talking to me today.
And best of luck, and I'll be paying attention to what you guys are up to.
Awesome. Thanks so much, Jay.
It was really fun talking to Jay the other day. If you have any questions for him or about Rackets, feel free to post any questions in the comments on YouTube or on Patreon. I hope this was a fun introduction to the Racket programming language, though. Bye, guys.